And we immediately start with moving the paper around. Okay. When we're solving rational expressions, notice there's an equals sign in here now. The first thing that we are going to do is change this first part a little bit. Make sure you check your answers. No, we don't want to do it that way because sometimes you're going to get answers that are fractional, and who wants to be going back and testing fractional answers out? That's no fun. So what we're going to do instead is make sure that your answer, or answers, sometimes we may have more than one, doesn't make the denominator equal 0. Because if it does, of course, then it's undefined, and then if it's not defined, of course, that's not really a solution. So instead of checking every single answer, we're just going to make sure that it doesn't make our denominator equal 0, and if it doesn't, good. We're going to say that's an answer, and we're going to go on about our business. So that's a good thing when we're going through these. So here's how this is going to work. We still have to find a common multiple with this, though. And we're still going to do that the way we did before when we were finding denominators. So for instance, on number 1, I still need to run through the checklist that we're always talking about that I've got over on the side board there. Which basically, again, because if somebody's looking at this later, they won't see the sideboard, is we are going to check for coefficients first. So as we're working through these and we're looking for a least common multiple, one of the things I'm going to do is look at my coefficients. Now here, I'm not going to have a lot of choices. They're both 3. Okay? If I start counting by 3s and start counting by 3s, what's the first number that's going to show up in both lists? Oh yeah, 3 is. So that's part of what we're doing. Also, we've talked before when we're looking at these about single variables. In other words, they're not bonded by plus or minus. When we have those, we always want to look for the one that has the biggest exponent. Well, here, again, it's just x and x, or x to the first. So that's all I'd use. I wouldn't use x squared. And then our last part of this is always to look and see if there are quantities, if there are sets of parentheses, but I don't have that this time. So my LCM is going to be 3x. So what do I do with that? I'm not going to build fractions this time. Instead, I'm going to take that value and I'm going to multiply it all the way through. So in other words, we're going to times this entire equation by 3x. So the first time we do it, I'm going to be very detailed in what's going on, and hopefully we'll get to a point where we can skip some steps here. But for now, just stay with me. So we're going to multiply the 3x times what I have in the numerator. So 3x times 7 would be 21x over x. Again, no messing with the denominator, just the numerator. Once I do that, 3x times 1 is 3x. Leave that alone. You're like, this is weird, Harty. We're used to having a common denominator. Oh, just wait. And then 3x times 5 is 15x over 3. Here's the part about this you're going to like. Since there's an equals, since there's an equation that we're solving, you can reduce these now. I can cancel the x's and just have the 21 left. Here I can cancel the 3's and the x's. I still have a 1 though. Don't lose that. If everything cancels, we still have a 1. And 15 divided by 3 is 5x. And now we just solve what's left. We don't have to worry anymore about common denominators and building fractions and stuff as much. So I go ahead and I solve that and I get my x value. But before I circle that and say I'm done, I want to check one last thing. And that one last thing is, does this cause my denominator to be 0? So I go back and I look at these and I say, okay, let's see, x can't be 0 because that would cause this. That doesn't hurt me. Well, if I set 3x to not equal 0, well, I still get x doesn't equal 0, okay? So as long as my x value isn't 0, which it isn't, that answer is A-OK. And again, you'll get an occasional no solution, but it doesn't happen a lot, so it's something we're going to keep an eye out for. Now that one's about as straightforward as it gets. There's going to be some twists and turns, you know that. There always is with these. So when I get up to the next one, thank you. So I look and I go, okay, those are parentheses, but wait. I always need to look and see when I'm looking at any denominator, can I factor it at all? Because that's going to help me make sure that my LCM is simpler. Can I factor anything here? Yeah, the x squared minus 4. What's that going to look like factored? Okay, x plus 2, x minus 2. And if that's still going, that you need to have out the factoring hot sheet, and you need to be working on the last quiz practice. Because this isn't going to go away, and me telling you every time isn't going to fix it on quizzes and tests. So I get that knocked out of there. And we're not going to be doing number 3, so if you need room here to the side, we'll head that way. What's my least common multiple going to be on this one? Yeah, I don't have coefficients this time, everything's in parentheses. I don't have single variables this time, everything's in parentheses. So then every different set of parentheses I see x plus 2, I see x minus 2. That's my LCM. In other words, that's what I'm going to multiply through this by. Now again, on these first couple, I'm going to be very specific on how I want to do this. So I'm going to write my LCM. And this is why we're not going to be doing number 3, because this is going to be a little sizable. And I'm going to recopy what I see for right now. Now the thing I show you right after this, I don't want you to write down, and some of you are like, well, shoot, Harty, I wouldn't have room for it even if you wanted me to write it down. Let me scooch this a little bit. And we're also going to start looking at how I can shortcut some of this and not have to write as much. Because if we were to do this one like we did the first one, I'm just going to flash this on the screen for a second. It's basically going to take up the entire screen. And you guys are going to be like, holy crap, dude, why would anybody ever think of doing it that way? And if you're visual, it may be something you do want to consider. But it's not something I necessarily would suggest because, as you will see here momentarily, do I really want that to be the next step that I put up? Because remember, that's actually what I'm doing here. I'm multiplying x plus 2x minus 2 times each one of my numerators. So I mean, I could do it this way and then cancel, 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 and go about doing it that way to get to what my answer is going to be in a minute. And if you are a very visual learner, you may want to do this at the start just so everything makes more sense that way. But here's what I like to do, and I think you will too because it's going to be a little less writing. I'm just going to look at this one piece at a time. And I'm going to say, okay, this is in the numerator. These are the same. They cancel. Whatever you see left over once those cancel is what you write down. So 3x, x plus 2, because those guys canceled each other. And that's what's left, the 3x and the x plus 2. And I go from fraction to fraction doing that. So I move to the next fraction and I say, okay, well this time the x plus 2 is canceled. So whatever I see left of my LCM, the x minus 2, multiplies by what's already there. So I still see the x minus 2, I still see the 1. I get that done. And then finally, I get to the one on the end. Ooh, the x minus 2 cancels. Ooh, so does the x plus 2. All that's left is negative 4. which would have been the same thing that I'd have got if I did it cancel way. There's the 3x, x plus 2. There's the 1 times x minus 2. And here, everything canceled except the minus 4. So either way works. Find one that works. And don't just say, I'm not doing it the other way because I don't like it. It's too much work. We got to do what we got to do to make this work out for us. So now I got my Algebra 1 work I got to do, and I'm done. Got to do a little distributing. So I'm going to kind of come up to here. So I've got 3x squared plus 6x. Get it done there. So do my distributing. And again, if some of you can do this in one step, that's okay. I need to combine my like terms. So I've got 6x and x is 7x. And wherever x squared is, that's where the party's going. Everybody's got to hang out on the x squared side. So I'm going to add my 4 over. You're like, oh no, not the Algebra 2 F word once again. Oh yes, yes. Yes, we must factor this to find our solutions. For time's sake and the fact that we have factored using slide and divide at least 1,001 times in here, I'm going to just go to the factored form. And then you just set those each equal to 0, and that's what your solutions, at least we think, that's what our solutions are going to be. And that's why we don't do a ton of these, because sometimes they can take a while. And even crazier yet, you're like, wait, don't circle yet. What can my x values not be? That's kind of important to know. What minus 2 is 0? That'd be 2. What plus 2 equals 0? That'd be negative 2. Do I have 2 or negative 2 as an answer? Oh. Can't have it. If it causes a denominator to be 0, doesn't work, doesn't work, doesn't work. Can't do it, can't do it, can't do it. And so we cancel that out that way. But again, as we get better at things, we're going to get to a point where we can just multiply by the LCM out here, do all this canceling without writing it out again, and it won't take up as much space. But I did give you more space on the worksheet because, well, I figured at the start we may need it. So as we kind of keep playing with this, and it's like anything else, the more we play, the better we're going to get. And yes, I know there's an adjustment to make on the worksheet. I will make it here momentarily. Okay. LCM. What is it this time? (3x). Okay. Because again, I've got my single variables, got my coefficient. So we're going to multiply through here by 3x. All right. We are going to try and do this step by step with mental math this time. We got this. So I look at this, and if I need to do a little side work, I can. Here, the x's cancel out and just leave me 3 times 3, which is 9. Now, if you don't see that, okay, then you'd want to go, okay, 3x times 3 is 9x. Okay, it's over x. Oh, the x's cancel. Just to have a little piece of paper where you can do scratch work. It's an okay thing to do. You're like, wait a minute, Harty. Well, what about this next one? Okay. It's just the numerator. There's going to be nothing to cancel. 3x times 12 is 36x. Okay. Nothing to cancel, nothing to even worry about. I'm just multiplying them together. Don't lose my equals. 3x times 2 is 6x. There's nothing to cancel in the denominator because it's just a 1. And then finally, now this one I may need some help on, maybe not. The 3x's cancel and just leave me with 4. But again, if you don't see that, multiply. 3 times 4 would be 12x. The x's would cancel, and that's what 12 divided by 3 is. Take it piece by piece. And again, once you get here, now it's just Algebra 1 stuff at work. Minus my 6x over, because again, I got to get all my x's to one side. Minus my 9 over, because I have to isolate my x's. And yes, you can get fractions for answers. Again, take one last look to make sure it doesn't cause a 0 in one of your denominators. Negative 1/6 there is not going to cause a 0. That'd only be 0. So yeah, we're good. But again, you've got to work this to where you're at. If you need to see every step, we write every step. If you can get around things and use your fingers and cancel and stuff, that's cool. But it all depends on what point we're at. Okay, one more of these, because we're actually starting with the hardest stuff. This is the hardest. It gets easier as we go down the page. All right, let me parentheses these guys up. Again, if you need some room, we're not going to do 6, so if you need to use it, use it. What's my least common multiple going to be? Any coefficients? No. Yes, I was going to say single variables? No. My LCM is just the x plus 1. So, I'm just going to rewrite it down here because it seems a little smashed up there to me if I do it up there. And again, if I just work a piece at a time, I can say, okay, the x plus 1s would cancel here. I get 5x. I move to the next piece. Harty, nothing cancels. Okay, if nothing cancels, I just do 4 and the x plus 1, because I'd multiply them together anyway when I distribute it, because this is over 1. And I get to the last part. Ooh, the x minus 1s cancel. It's just minus 5. And now we're back plain algebra 1. I do my distributing. That's why I put the parentheses to make sure I do it to the x and the 1. Combine my like terms. Thank you. And subtract my x over. But again, make sure that your answer doesn't cause a 0 in the denominator. Is negative 1 going to cause a problem? Negative 1 plus 1 is 0. Okay, that didn't work. You're like, well, what the heck? That was my only answer. Well, then we have no solution in that case. That can happen. Okay, and I have to watch out for things like that to make sure that they don't. But again, it's all about finding that least common multiple. If you need the practice, we've got to keep working at that. Go back to 9.3 when we first started doing this stuff and check into it some. Now, so far, everything's had one answer. Sometimes it may be 2 answers. It works the same way, though. Do I have a factorable denominator? Yes. Okay, difference of squares shows up quite often with these. X plus 1, x minus 1. And again, if that's an issue still, you've got to go back to the factoring stuff. Because what that tells me this time is, there's my LCM. I have an x plus 1, I have an x minus 1. I don't need another one. It goes here. So, I get that boxed in. I get my x plus 1, x minus 1 outside. Because again, I'm going to multiply all the way through by it. And once I've done that, just like before, we're going to go through piece by piece. Okay, the 5x will be there. The x minus 1's cancel. I have the x plus 1 left. And again, if you need to write it out, some of you may want to see it visually like this and then cancel what's left, and you'll get to what I'm at here. Okay? That's a fine way to go about it. That'd never be a bad way to do it. You're like, ooh, the next one though. Harty, there's nothing there to cancel. Do I have to have them both? I do. And we'll come back and deal with that momentarily. And then with the equals, this time the x plus 1 and the x minus 1 cancel. And all I'm left with is the 14 that's up top. And again, if I wrote that out, since that's what I'm doing when I distribute, cancel, 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 cancel. Okay, it's 14. So you're like, ew, but this is going to kind of get ugly. Not really. Distribute with my first part. Now when I get here, I need to FOIL this back out. But remember, oh yeah, that was x squared minus 1 when I FOILed this out before. So I'll just use that. Again, take things in bite-sized chunks. If you try to do 3 steps at a time, just like you would if you were eating a piece of food, it'll kind of make you choke a little bit on it. You'll be like, ugh. But we don't want to do that. So I get here and I'm like, okay. Distribute the -2. Be careful. Negative times negative is positive. It would suck to go to all this work and then put -2 and have everything go bad. You're like, oh, let me guess. They're squared, so I have to put everything on the squared side. You're genius. 5x squared minus 2x squared is 3x squared. That's my only x term. And then 2 minus the 14. And yes, people, we would be back to slide and divide or whatever it happens to be. Whether we're doing it with mental math or slide and divide, it has to be factored. There is no way around it. So once I've gotten that taken care of, I set those each equal to 0. Let's see, add my 4 and divide by 3. And neither of those, the only answers that would have caused me trouble were 1 and -1. Neither of those were an answer. I'm done. So again, it's going to take some patience to be able to get you there. So then our last one in this section, then we get to do the easy ones. I saved the easy ones for last. What's our LCM going to be on number 8? I was going to say, it should be a roaring agreement of about 27 people. X. X, all right. Everybody out there can tell, we can cut the excitement with a knife here. All right. On my first term, there's nothing to cancel x with. So it's x squared. On my second term, the x's would cancel each other and just leave me with 24. And then when I get to my last term, again, there's nothing to cancel the x with. 5x. You're like, we know. There's an x squared term. Get everything to the x squared side. You're right. Minus the 5x over. Again, it doesn't combine with the 24 because it doesn't have an x. At least this time it's only a diamond. Let's see, multiply to a negative means the negative's bigger. Problem, 0 is the only problem. We don't have 0. We're okay. So multiply through by the LCM, and then basically it's Algebra 1 skills that we're going to be using to try and finish that up and solve that. And then we can finally get to the easy part. You're like, about time there's something that's easy. Now, Harty, do you mean easy, or do you just try to be a smart aleck? No, I really do mean it. If there's no pluses or minuses between terms, if there's only one term on each side, one fraction, go ahead and solve it by cross multiplying. But, as we always say, if you see pluses or minuses at the start of a problem, if there aren't parentheses, you put them in. You're like, well, could I do the same thing I've been doing with the least common multiple? You could, but you're going to end up in the exact same place. It's just going to take more work. So I'd just as soon rather cross multiply and work. And again, we just go back to some first semester Algebra 1. Let's go ahead and solve for x equations. Minus the 6. But still make sure, you know, does it cause a problem in my denominator? Negative 8 minus 5 isn't 0. Negative 16 plus 3 isn't 0. So that's okay. So then our last one. Some of you are like, thank God. Okay. Again, once we cross multiply, we're going to do some distributing. Oh, I see an x squared term. We know what that means. It means everything to the x squared side. Yes. I'm going to minus 6x over, so negative 1 minus 6 more is negative 7. I'll add my 10 over. Little diamonding to do. Let's see. Double negative. Add, multiply to 10, add to 7. Is 2 or 5 going to cause a problem? 6 minus 5 is 1. Nope, that's okay. 15 minus 5 is 10. Nope, that's okay too. Now, I'll actually stop this here.